let's go now in some detail of these individual blocks. So, first of all, basic services. It's always good, if it is possible, but it's always a good design property to separate as much as possible, if you can, data from logic. So this is the old three-tier or n-tier, let's say, architecture for software system, and it's also valid for services. So if you can, it's good to devise some data-centric services to handle data, and typically in this kind of services what you find is your typical CRUD operations, so create, read, update, delete, and you are abstracting the storage, the retrieval of data, the mechanism for locking, maybe transactions. So what I'm saying about data-centric service doesn't mean that you don't have logic inside it, but you can put inside these data-centric services the logic that is needed to deal with the data, not with other things which are higher levels and are typically of other layers of this stack. So you can utilize whatever you have as a data storage, typically a database. We will use a database, file system, and in some case, I mean, believe it or not, there are also a lot of banks that have tape libraries, so these are legacy systems, and you are essentially writing services that are reaching this data. Another possibility, which is not written here, is that sometimes the data is maybe taken from the web. So you're scraping the data from something which is not built as a real database. So there are also some non-traditional sources of information that you can wrap in these data services. So this layer of services, data-centric in particular, these data-centric services are very similar to the data access layer in traditional application, entire application. But the difference, the kind of difference that you can find is that while data access layer manages all type of data, and it's a kind of a horizontal slice on top of your data, typically, data-centric services, since they are, you can obviously write a big data-centric service that handles all the data that you have in your application, but what is most useful is to slice it vertically. So you have one particular part of the database that is access to this service, and it provides information about customers. Another one which provides information about billing or other information system, other data. So it does not mean that you have to have different databases. You can have maybe one single centralized database, but these data-centric services are sliced vertically on particular specific entities of your data. Another point, these are again suggestions, okay? Best practice or guidelines on how to build this kind of services. Usually it's good practice to encapsulate strictly your service on a particular data that you are using. So let's say, obviously these things works. I mean, both of them work. One is that you have, let's say, one particular customer database, and you are building two services, one which is providing access to the customer data, and one to the itinerary, which is also using the customer service. You can build it as independent, but it's much better to group them together in a particular service that provides more than one functionalities. So you can have one interface for the customer manager, one interface for the itinerary manager. These obviously can be much better designed and implemented with SOAP kind of services rather than REST, but you can also do it as a REST. And these are combined together in a particular specific service. So the granularity and the ownership of the specific slice of your data should be in the hand of one single service. And we will see what this is also has some implication later. Designing obviously falls the things that we have been saying to be self-contained, and the tools are very similar to the tools that you're using for business domain modeling. So entity relationship models or object-oriented designs, and but in this case, cross relationships are not allowed, should be avoided, because you want to have it as loose coupling as possible in between your services. So while in the entity relationship models, you can navigate and you can connect from one entity to another, as you know. Because that's what we want to, what we strive. So the tools that you have there, it's the standard tools, but remember to have as little as possible connections between different services. Within one particular service, you have obviously all the connection that you want. This slide is just to remind what I already said, that it's not that the data is just a pure wrapper of crude operation. You can also put, and it's also, let's say, important to put inside these services all the logic that is inherent to that particular data. If you have formats, if you have information about the data, it's here that you need to put the logic on how to process this data, but only the logic to the data, not the logic of other business process. The logic can be, again, it's a possibility, and it's a good practice to put it in a different kind of services that is typically using the data services to arrive at the data, imports this data to inside the service and starts to process this data with a particular logic. So at this level, the kind of operation or features that you want to do, they are not complex. They are not made of many different implications. You are just using one particular kind of function. So again, what I'm pointing here is the fact that both the data-centric and the logic-centric services at this level, they should be, if you want to follow this kind of architectural design, should be stateless. So they need to be standalone. In Italian we would say a sé stante. So it means that they need to work and be able to work without having any other information apart from the input information that is given, and eventually the logic that is inside of them. So examples, and most important also, if you want to implement these distinctions between data and logic, they should not be allowed to modify data. So they only read data and they do not modify data. Maybe they produce new data, that's a different things, but usually they don't modify, they process the data, but they don't modify the data that they have started with. They maybe create some other things. And these are a number of, let's say, examples that you can think of. In scientific application, you are just maybe running a simulation, you start collecting your data. On the base of this data, you are producing with an algorithm some other data and some output. That's probably the most simple ones. But in the business cases, you have to check, for instance, the logic of the home loans eligibility. So you are taking all the data from your customer database, all the data that is relevant to implement a particular policy, and you come up in the in an easy way with a yes or no answer depending on the data. So these are just simple examples of logic-centric application services. Now, the next level that we have presented is the so-called level of intermediary services. These can be there, cannot be there. It will depend on your application. What you usually find in this layer are, as it is said there, stateless mediators. So again, you don't have any information prior or after, but just you are executing on the data that is provided or the information that is provided, or the documents that is provided and input, and usually are used to bridge technological inconsistencies, which can be technological from the point of view of protocols, from the point of view of data formats, and or design gaps in the architecture, because you want to make talks to system, to services, which are not aligned technologically and on the data level. So remember that these is a layer of services that it's very useful where if your focus is on enterprise application integration. It's very useful because it's typical that there exist the technological inconsistencies. The technological inconsistency can be there because of history. One division went with one database, another division went with another database. It can be because you are merging together, you are restructuring enterprises, you are acquiring a new business inside your system, and you have to cope with information systems which are different. So you are typically talking about technology gateways, adapters. We will see individually what they are, which are typically provided already directly by the enterprise standard bus, enterprise service bus, or can be just made by you if you need them, or you are just combining together services, existing services into new services, and you can do that by using the so-called facades pattern, in which you are just combining existing services into new one, or you are just adding functionalities with functionalities adding services. And that's the typical, some examples, like with some maybe diagrams which are much better than words. This is the typical situation that you have when you're talking about technological gateways, in which you have a service which provides the API with a particular technology, maybe SOAP or REST, and you have another application front end which for historical reason is using a different technology, and so you need to build a gateway in between which just translates one protocol to another. That's a simple one. You can always think it also as data, but with the data, normally the ones that are related with the data are called adapter services, and they are also very common. For instance, you have a booking application that provides information. You have two airlines. That's probably better to start from the bottom. You have two airlines which have different databases and different services on top of this database, basic service on top of this database, which is provides different formats. So you just using, and the airline one is using can use directly this customer service service, but airline B cannot, or maybe an integrator of airlines cannot use it. So you just build adapters. You don't change anything in the booking application. You don't change anything in the original basic service. You just write an application that translates. Typically, this is done with XML style sheets, transformation, and processing, because most of the time the interfaces and the data are provided through XML messages, for instance, SOAP. So it can be done very well with Excel LT, so the transformation of the style sheet. And these are very, let's say, big categories. Unfortunately, in reality, this is also a lot of work in the transformation on alignment of different databases. The facade is something slightly different from the previous two ones, which are, one are related to the technology protocols and one to the data format. Sometimes, I don't remember if I have, we have some examples later in some later slides. Essentially, here is that you want to provide a unified view of a number of underlying services. Clearly, you could build a new basic service, like a logic basic service on this, but sometimes you don't want to do that because you want to maintain that the previous services can be used in the same way as it was before. So you just agglomerate a number of services, and typically their use is in single projects as interim solutions. At the end, if you want to have a better design, I mean, so it's, let me say it's just a kind of a hack sometime to find a solution when you have, then when your system is evolving in a more stable way, they should disappear. And the same is the functionality adding services. This one is the part that I've already said. Now we are moving one step up. We are moving on the process-centric services. And here we have a big change. So up to now, basic services and intermediate services, they are stateless. It's good if they are stateless, it's a good property, okay, let's say, because you can always do whatever you want with your services. But from the design point of view, should be stateless, so that you can use them much more easily. At this level, in place, at a certain point, you have to put the state, in particular if you want to do a long-lived or short-lived or long-lived process, if you want to implement something which has a meaning for your particular domain. Your particular domain can be a bank, so you have to follow all the transactions from one hand to another. The approval of a loan can be the acquisition of a flight ticket. I think that in the remaining slides we will follow this example. So you want to have an initial moment in which you start doing your process. You go through the process, you make some selection. On the basis of the selection of the information that you are gathering of the flight, in the case of the flight that the customer is gathering, there is a choice, and given of this choice, you have to go through a process of maybe paying for the ticket and receiving some feedbacks and ending this process with the ticket in your hand or in your email boxes eventually. And some of these processes can be also long-lived, so you have also to think about this. So this is an interaction that can be arbitrarily complex, so it's not limited only to request-response. You must have also maybe the input of a human. In the case of the flight, you have to select at the end. You can propose the best route, but at the end there is a selection which is made by a human. Two ways of doing this could be a wired-in service in which all the various possibilities are written and hard-coded in your service. So your service essentially follows all this procedure inside, and this is something that eventually we will do in this course, because the other way is to use a meta-language. That is, you are using a different way of programming in which you are not using essentially a programming language, but you're using a meta language that is typically in this case designed for connecting and composing different services. Obviously, the second solution is a much more flexible solution because you only define the pattern and you can map it directly or more or less directly, semi-automatically, let's say. There are also some automatic tools to do it from the business process model that you have of a particular process and the services without the need of any programming. Or maybe you need to use this meta language. One example of this meta language is the WSBPEL, or just BPEL for short, is the web service process execution language that does this for you. Okay? So what we will do in this course is we will write the code. We will use Java or your preference programming language to join together, to compose together the services, but this can be done also with a different tools, with a more abstracted tools. That's the typical slide to present the integration among different enterprise silos. So each one has its own database, its own application logic, and one way to integrate it is by providing a layer of service on top of each individual information system and write the business process that governs these services. Another way of looking at it is by providing, let's say, services for the data, in this case, on that side, and then this supplier, which is the order management service, it's in reality an application which follows a certain logic of the process and a certain number of calls to implement a particular process. In this case is the order management of a particular good, which is a standard example in e-commerce. And it goes to the customer. So since we are at the process level service, that's the user is just a customer, and there is no need to implement any other things on top. The next level is the public enterprise services, where essentially you can, by remaining on this slide, you can substitute this customer, maybe another similar box, because the customer can have its internal procedure and as well. For instance, in the case of university, when you are acquiring a good, there is an internal procedure that needs to be followed. So you can imagine a symmetrical kind of things with obviously different process, because this is the process of the supplier and this is the process of the customer. This level, it's the so-called level of public enterprise services. So the process services are dealing only inside one, let's say, ownership domain, and the public enterprise services are dealing with the connection between two different ownership domains. So each layer contains distinct type of services, and this we have, it's just a list of what we have done. So this leaves us with the last part of this lecture on design principles, which is types of service-oriented architecture. So let's see, once we have all these building blocks, which are already organized in a kind of hierarchical classification, you can do many things. You can do what is so-called fundamental and elementary SOA, network SOA, and process-enabled SOA. And our aim at the end of this course is to cover essentially all three of them and to give a final sample, which is a process-enabled SOA. So to implement a service-oriented application, a process through a service-oriented applications. So let's talk about fundamental SOA. I will first introduce the example and then go through some diagrams that are better. And the wording of this diagram, you find it in the slides. So let's look one particular example, which is the airline application. So you have typically in a traditional old-styled way, you have the airline website, which has its own database of booking data. You have a billing application somewhere else in your system with, again, billing data. And you have a customer care application. This is some typical standard database which are present in any enterprise, and in particular, in this case, of the airlines. One way to align the data among themselves in order to integrate the three different systems, each folder here is an information system, is to produce data and then update. Here it says nightly, but sometimes you want to do it maybe not only nightly, but in at interval of times. One way to make it service-oriented is to define on top of the database. So we are abstracting now on the real database, which are inside the individual services. And remember, the database can be shared, so you just have only the flight information of your database, only the booking, and the database can also be distributed. Only that each of these individual data services, very probably in this case, are dealing with its particular type of data. And the fundamental example is essentially you have only two layers. You have the basic layer and the enterprise layer. That's it. So you are just developing, in some cases, in some simple cases, this is possible. You are just developing your data and logic, maybe, for the booking, in this case, probably, services, and directly from the enterprise layer. At this stage, at the enterprise layer, we have already the front end, in this case, or the website, or individual application that are calling the individual services and are making use of them. So the airline website very probably used by the customer, the billing application maybe by the travel agency, let's say. The next step is we can do, once we have these components, the interesting thing is that once we have these components, which can also improve, the example is simple, but you can imagine to enlarge it in various directions, in various domains. You can have, for instance, the possibility, in place of using two entry points, the website and the billing application, you can have only one entry point, the website, because you can build a facade service in the intermediate level, which deals with a particular part of your problem. So the customers arrive and selects the flight, gives the customer information. If they are there, they are retrieved. Otherwise, they are created or updated. And then it can move to a different part, again, with no state involved. We don't have the process here yet. It's just a selection of the user at the website, which selects, now I'm doing the booking, and now I'm selecting the flight first, and now I'm doing the booking. There is no process which is built inside the website. It's left to the user to implement the process. And that's also an easy possibility. So what does this service is just combine and encapsulate all the transactional problems which have to do with the booking. You have to first know that the flight is there, you have to pay, you have to receive the payment, and then finally you have the confirmation. Another example of intermediate layer is, for instance, the support of different types of technology. One typical application for flights is a standard. Is this CICS, which I don't remember what it means, but anyway, it's a standard for the flight. And there are different kind of front end. That typically is a website, but can be maybe at the check-in desk, or it can be a business-to-business portal which is used by travel agencies to directly connect with them. So if you have this service, each of these should write its own particular, let's say, hook and way to arrive to the service, or much better design is to introduce specific services which work on top of this one and are able to bridge the gap, the technological gap. This one is probably based on Java Beans, so it's web-based. This is maybe a different application developed with .NET, so it's a standalone application with its own graphical user interface. It's not web-based, and this one is just a direct end-to-end, maybe line command terminal user. So that's another way of using these design patterns for solving enterprise application integration. Or another example using the adapter pattern is that the two applications, the booking and the CRM, which are at the top level, are working on individual and different implementation of the database. So the old way of integrating them was for for instance, by nightly batches in which you run the batches and you align the two databases, which are different databases from each other. They are on the same entity, but they are different. The other way is that you could use another layer and put an adapter, so you're using only one database, one of the two, but you are adapting the other one, which uses, CRM in this case, uses the different data formats with an adapter. So adding these intermediate levels allows you a higher level of flexibility in the integration. That's the whole message here. One step further, always following this flight search and booking example, is to add the layer of the process layer. So in the previous case, without this step, it was the user who was going to essentially pass from one mode, which was searching for the flight, to the booking and billing process. But obviously, this can be wrapped around a service which takes care of the composition of all these various parts. So the flight is a read-only. You can just request some flights. But then at a certain point, once you have selected your destination, you have to move through a process which needs the information of the customers. When you are in the searching mode, you typically need the information. And then you need to go to the booking, and then you have to go to the book and bill, because this has to be wrapped together, because you pay and you have to be sure that you get the ticket. So it must be done within a transactional kind of environment. And these are the so-called process-enabled SOA. So even if it is a simple application, we can see how we can introduce these different levels one step at a time. And the previous one was an example of a short-lived, in the sense that you do it and you get your ticket. Sometimes, not all the airlines provide these services, but big airlines, they do. You can also cancel your ticket, and maybe if you have paid enough, you can also not lose your money, or at least not all of your money. This is a typical example of a long-lived transaction. So it does not end only when you have booked your flight and you got your ticket, but it is there, and it needs to reconnect again, probably. You do it days after, or weeks after, sometimes months after, and you have to reconnect to this one. So this is well done in this way, with probably a different process. So the booking process has terminated, but then you have a different cancellation process that can call again the booking process and can do modification, is allowed to do modification on the booking process. So these is just given to you as an example of long-running processes. And that's it for the lectures today. Here are some reference and readings. So the idea of next time that we meet is to take one example, not this one, because this is done, and try to figure out in practice, so your work in this case is going to be not a lab, because we will not use the laptop, but we will use paper, pens, pencils. We will draw things in order to start to have this kind of diagrams to see if it is a useful approach to you in your design phase. Okay, thank you.